section. Let's take a look at something you did last year in Algebra 2, and that was adding rational expressions together. Well, we know to add fractions together, you have to have a common what? You have to have a common denominator. And how do you find the LCD? You need to make sure both denominators are factored first. I can't factor x minus 3, but can I factor 3x minus 9? Yeah, so first thing I want to do is I want to get those denominators in factored form. So what factorization am I going to do on 3x minus 9? I can factor out a 3. So now I'm going to identify my common denominator. Now that everything's in factored form, you can identify your least common denominator. And what is the least common denominator going to be? 3 and then the x minus 3. So remember, what you need to do before you can actually add these fractions together is you need to make sure you rewrite each fraction with the common denominator. Look at your first fraction. You already have the x minus 3, but what piece are you missing? You're missing the 3. So you're going to have to multiply the numerator and the denominator by the 3. So I'm going to distribute the 3. That's going to give me a 3x plus 6 over 3 times x minus 3. Your second fraction already has the common denominator, so I do not need to multiply by any missing factors. So now remember, to add fractions together, you leave the denominator alone and you're going to add the numerators together, combine your like terms. I cannot add 3x to 2, so I'm just going to bring the 3x over. And then 6 plus 2 is 8. Now, after you get done adding, remember, if you can, you want to make sure you factor the numerator and see if you can cancel any common factors. I can't factor the numerator, so this is my final answer. All right. So any questions on adding rationals together? Yes, Monica? No, because there's no 3 in there. Remember, you can only cancel factors. You can't cancel terms. So if you can't factor that numerator, you can't do anything. You've just chopped your head off your animal. All right, not to be a graphic description, but again, remember, this is one whole animal. There's actually parentheses around that 3x plus 8. So if you can't yank anything out of that expression in the numerator, then there's no canceling you can do. You've got to get it in factor form. All right, so let's take a look at some examples now. So again, I'm giving you two functions, f of x and g of x. They want me to find the following and then actually state the domain in each case. Now, just to make sure you're comfortable with function notation, the parentheses f plus g of x is actually equivalent to them saying take f of x and add g of x to it. So they are equivalent expressions. So sometimes they'll write f of x plus gx as two separate, or you'll see one big set of parentheses that says f plus g of x, but they're equivalent. So I need to take f of x, which is x minus 3, over 2x plus 5, and I'm going to add it to g of x, which is 3x plus 5 over 2x plus 5. Well, that's nice. The fractions already have the same denominator. So I can just go ahead and I can add across. So again, remember, I can just keep my denominator and add like terms in the numerator. So x plus 3x is a 4x, minus 3 plus 5 is a plus 2. Can I factor the numerator? What can I yank out of the numerator? I can yank out a 2. So that's going to give me a 2x plus 1 over 2x plus 5. Again, I can't cancel any like terms, so that would be my final answer. Now, remembering back from last year, how do you find the domain of a rational expression? Right, we have to set the bottom equal to 0 because remember, anytime you have a 0 in the denominator, it makes your fraction undefined. So we have to find the x value that's going to give us a 0 in the denominator. And what's that x value going to be? It's going to be when x is equal to what? Negative 5 halves. So the domain, remember, is going to be then all real numbers except negative 5 halves. So any questions on adding? That's a negative 5. I'm sorry, my pen just kind of slipped. It's a 5 right there. So if you subtract, again, f minus g of x is equivalent to writing f of x minus g of x. So again, I'll take my f of x, which is x minus 3 over 2x plus 5, and I'm going to subtract g of x from 3x plus 5 over 2x plus 5. So luckily I already have the same denominator, so I don't have to worry about finding a common denominator. But you need to be careful, guys, with subtraction. Like I just mentioned, there's actually parentheses around the numerators and denominators of fractions. So when you're subtracting, be careful. You need to make sure you distribute the subtraction sign all the way across to each term in the fraction that comes after the subtraction sign. So when I subtract, x minus 3x is a negative 2x. Negative 3 minus 5 is a negative 8. And what can you factor out of that numerator? You can factor out a what? Negative 2 or 2. So if I pull out a negative 2, that'll give me an x plus 4 over 2x plus 5. And the domain would be the same as part A because the denominators are the same. It's going to be all real numbers except negative 5/2. Okay. So any questions on adding or subtracting functions together? What operation are we doing in part C? Is that what I wrote on the board a few minutes ago, that F open circle G? Or is it a different operation I'm going to do in part C? Is this composition or is this multiplication? Which one is it? Multiplication. Remember, the open circle is composition. This is a closed circle, so this means you're simply going to multiply. So f of x times g of x. So again, I'm going to take my f of x, which is x minus 3 over 2x plus 5, and I'm going to multiply it by 3x plus 5 over 2x plus 5. Remind me again, when I multiply fractions, do I have to have a common denominator? No. So again, unless you love foiling, you don't need to FOIL out the numerators and denominators. Again, I'm just going to multiply straight across. That's going to give me x minus 3 times 3x plus 5 over 2x plus 5 to the second power. Unless you love foiling a lot, be my guest. You don't have to. I accept that as an answer. And again, the domain's going to be all reals except negative 5/2. That uppercase R, in case you've never seen it before with the two vertical lines, that is set notation. That means all real numbers. So that's an acceptable R to write to mean all real numbers. What operation's happening in D? Division. So remember, this is really telling you to take f of x and dividing it by g of x. And I've mentioned this before. Remember, division can be written two ways. Division can be written vertically. It can also be written horizontally. So remember, division can be written one of two ways, vertically like a fraction, or written horizontally. So if I want to divide these two fractions, f of x is x minus 3 over 2x plus 5, I'm going to divide it by g of x, 3x plus 5 over 2x plus 5. Remind me again how we divide fractions. I have to take the reciprocal. Which one do I flip, the first one or the second one? Second one. Remember, you flip the fraction that comes after the division sign. So x minus 3 over 2x plus 5 times 2x plus 5 over 3x plus 5. Remember, when you multiply, you're allowed to cross-cancel common factors. Can you cross-cancel anything? Yeah, we can cross out that 2x plus 5. That leaves you with x minus 3 over 3x plus 5. Now, what's the domain of this one? This domain is going to be different. The domain is going to be what? All real numbers except what? Negative 5 over 3. Okay? So any questions on adding, subtracting, multiplying, or dividing? And again, especially when you're dealing with these rational expressions. Again, when we talk about composition, like I wrote on the board, when you see this open circle, composition of functions, you may see f, which I always call it the fog notation, it looks like fog, is actually f of g of x. Remember, what this is inputs and outputs. You're putting something in, you're getting something out. when they ask you about the domain of a composition, you have to consider not only the domain of your final answer, but the domain of your input function. So in other words, you've got to look at the domain of that g of x, and you've got to put the two domains together. So that's the trick when you're talking about domain of composition of functions. So let's take a look at some function notation. So I'm giving you two functions. What's g of 4 asking you to do? Plug 4 in for x. So that's just straight function notation. Remember, 4 is the x value, so I'm going to take 4 and plug it into function g for x. So 4 times 4 is 16. F of negative 1. Again, negative 1 is an x value. I simply plug negative 1 in for x for function f, and what's my output going to be? What's f of negative 1 going to be? Negative 1. So now let's take a look at C. What operation am I doing in part C? This is not multiplication, but this is your composition. I always prefer, when I see that open circle, I always prefer with composition to rewrite it with parentheses. Remember, when you do composition, you always work inside out. So first thing I want to do is I want to find f of 2. So I'll take 2, plug it into function f. So f of 2 then is going to be equal to 2 times 2 squared minus 3. So what is f of 2 equal to? F of 2 is going to be equal to what? 5. Now I look on the outside. So the outside function is also f. So I'm going to take 5 and plug it into function f for x. So I know that 5 squared is 25. 25 times 2 is 50, and 50 minus 3 gives me 47. Because like I said, that's composition, you always work inside out. You find whatever is on the inside first. So like I always take my finger and cover up what's on the outside. Replace f of 2 with 5, and then look to see what's on the outside. So looking at D, f of g of negative 2. Again, this is another composition, f of g of negative 2. Again, cover up what's on the outside and look what's on the inside. What is g of negative 2 going to be equal to? G of negative 2 is going to be equal to what? Negative 8. So I'm going to replace g of negative 2 with negative 8. Now look on the outside. I now want to find f of negative 8. So I take negative 8 and I plug it into function f. So 2 times negative 8 squared minus 3. Well, 64 times 2 is 128. And 128 minus 3 is 125. You guys go ahead and try E for me on your own. I came up with a 20 there. Okay. So we did composition involving numerical values. Now let's take a look at composition involving our functions. So again, here we have g of f of x. So again, if I rewrite this as g of parentheses f of x. Again, remember, cover up what's on the outside and look on the inside. F of x is the 2x squared minus 3. So I'm going to replace f of x with 2x squared minus 3. Now I'm going to look on the outside, and the function that's on the outside is g. So g of x is equal to 4x. Remember, inputs and outputs. 2x squared minus 3 is my input. I'm taking 2x squared minus 3 and I'm replacing the x with the 2x squared minus 3. So what I always do is I take the 4 and I usually just draw a big line. So g of x is 4x. Take out the x. What I'm replacing it with is the 2x squared minus 3, and make sure you leave parentheses around the 2x squared minus 3. So any questions on how I did that input? Again, you can leave your answer in factored form like this, or if you distribute, that's absolutely okay as well. Either answer would be okay. All right? So any questions on composition involving functions instead of numbers? Remind me again, am I going to get the same answer as I did for F for part G? Are they going to be equivalent? No, remember, this is F of G of X. Cover up what's on the outside and look on the inside. G of x is 4x. So I'm going to replace g of x with 4x. Look on the outside. The outside is function f. Again, f of x has a 2x squared in it. So I'm going to take the x out, and I'm going to replace it with something else. So instead of having 2x squared minus 3, I'm going to replace that x with a 4x. Again, leave parentheses around that 4x. Any questions on how I did this substitution? Order of operations, what's going to come first? Do I multiply 2 times 4x or do I square 4x? You want to square 4x. And what is 4x squared? 16x squared times 2 minus 3. By order of operations, what do I do next? Times 2, so it's 32, x squared minus 3. Okay? So any questions on that? Now let's go down and take a look at tables. So like I said, we did composition and adding and subtracting algebraically. Now what I want to do is take a look at how you do it from a table. So notice they're not defining f of x and g of x. We have no idea what equations these are coming from. They're giving me a column of x values. They're giving me the outputs for f of x and g of x. So these are the y values for f of x. These are the y values for g of x. So when they want me to find f of 1, remember, 1 is an x value. So on my table, I find where x is equal to 1. So for function f, what is the output going to be? The output's going to be what? The output for function f when x is 1 is what? 8. So your answer is just 8. Again, f of g of 3, this is a composition. Remember, when you do composition of functions, you always work inside out. So again, look at g of 3. Remember, 3 is your x value. So find where x is equal to 3 and tell me what the output is going to be for function g. The output is going to be what? 4. So g of 3 is 4. Now look on the outside. I want to find f of 4. So when x is equal to 4, what is the output for function f? 2. So any questions on A or B, how I did those values from the table? So for C, g of f of 3. Find your f of 3 first. So when x equals 3, the output for function f is going to be 5. Now look on the outside, and you want to find g of 5. And what is g of 5 going to be equal to? G of 5 is equal to 7. You guys go ahead and do the next 3 on your own. 8, 1, and 7. So any questions on reading the table? Okay? So again, you just did composition using a table. So the next type, like I said, we did algebraically, we did tables, now we got to talk about graphically. All right, so now remind me again, when you see a line or any graph is made up of an infinite number of what? Points. Remember, a point has an x value and it has a y value. So when you're trying to do function operations from a graph, you're looking at points on the graph. So they're giving you the x coordinate. What you need to then do is find the point on the graph and figure out what the y coordinate's going to be. So f minus g of 1, what this means is I need to find f of 1 minus g of 1. That's what that notation means. So they're giving me 2 functions, 2 lines. Again, I'm going to highlight. So f of x I'm going to highlight in my pink. G of x I'm going to highlight in yellow. So what I'm going to do then, first of all, to find f of 1, remember, 1 is my x value. So I want to find 1 on my x-axis. And I've highlighted line f in pink. So I want to find the point on line f that has an x value of 1, which is occurring right here. What is the y coordinate when x is equal to 1 for f? That's going to be 1 comma what? 0. So then what is f of 1 equal to? F of 1 is going to be equal to 0 minus. Now I want to find the point on line G that has an x coordinate of 1, which is the point right down here. So when x is 1 on G of x, the y coordinate is going to be what? -1, -3. So then what is G of 1 going to be equal to? G of 1 is going to be equal to what? -3. And then you can subtract. Because f of 1, remember, the y coordinate was 0. Because you had to find f of 1 first. Right. Yep. So this is just going to be +3. Okay. What operation is happening in part B? G divided by f of 3 is just the notation for taking G of 3 and dividing it by f of 3. So again, to find G of 3, remember 3 is an x value. I want to go to 3 on my x-axis. So what is the y coordinate on line G when x is equal to 3? The y coordinate is going to be what? For G of 3, it's going to be 3 comma what? 1. So then G of 3 is equal to 1 over f of 3. So again, on my pink line that I've highlighted, when x is equal to 3, what's that y coordinate right here going to be? That y coordinate is -2. So then this is going to be -1/2. Okay. Any questions on how you can do function operations from a graph? Yeah, Chloe. F, yeah. Mm-hmm. Okay.
So do you find where x is -1 on the f graph and then you multiply it by?
No, this isn't multiplication. This is composition.
Oh, okay.
This
and
is.
Find out where it's -2.
Yep. So that's f of f -1. You guys go ahead and do the next 4 for me. My grid lines. Your eyes are better than mine, so if I miscounted, let me know. Any questions on doing the composition or doing any of these problems using the graph? We good? All right. Last thing, your favorite, just because I know you guys do not like simplifying complex fractions, but complex fractions come up quite a bit. Here are 2 functions that are rational expressions. We're going to perform these function operations, and notice they want you to also state the domain of the composition function. So here, what operation am I doing with this open circle? Is this multiplication or is this composition? Composition. So remember, this is your f of g of x. And again, anytime I see that open circle involving composition, I immediately rewrite it into the parenthesis notation. Again, remember, you always cover up the function that's on the outside and you look on the inside. G of x is equal to 4 over x minus 1. So G of x is my 4 over x minus 1. What I'm going to do is I'm going to take 4 over x minus 1 and plug it into function f. Now this is what you have to be careful of. The last examples when we were doing composition, one function was a quadratic and the other one was a line. So the domain of both those functions were all real numbers. When you're doing composition and they talk about domain, you not only have to look at the final answer, but you have to look at the domain of the input function. What is the domain of 4 over x minus 1? The domain's all real numbers except what? 1. So now what you have to do is consider 1 is not going to be in the domain of the final answer. Think about it for a minute. You're taking 4 over x minus 1, including all of those x values. You're plugging it into function f. However, 1 is not an x value in this particular fraction. It's not there. So if 1 is not there, I can't plug it into function f and have it be a part of the final answer. So when you're doing domain of composition of functions, immediately what I start doing is once I recognize what function is going in, I start writing the domain. Does that make sense so far? So now I'm ready to take 4 over x minus 1, plug it into function f. So again, in function f, I have 1 over x plus 2. Remember, I'm taking out the x, and I'm going to replace it with 4 over x minus 1 plus 2. So remember, I took the x out, and I replaced it with that input of 4 over x minus 1. Now, how do you simplify complex fractions? Remember, you're going to multiply everything by that LCD. So what am I going to multiply everything by? Multiply everything by x minus 1. Remember your LCD trick. The idea is you want to have the fraction in the denominator disappear. So when I multiply 1 times x minus 1, that's just going to give me an x minus 1 over. What happens when I multiply x minus 1 by 4 over x minus 1? Those x minus 1s cross cancel. And what are you just left with? You're left with a 4. Distribute the 2, so that's going to give me a 2x minus 2. What does that denominator now simplify to? Combine your like terms. That's going to simplify to 2x what? Plus 2. So there's your final answer. Again, yes, if you factor out the 2, that would give you a 2 times x plus 1. Now you need to look at the domain of your final answer. What's the domain of your final answer? All real numbers except what? Negative 1. So the domain is going to be all real numbers except 1 and negative 1. So remember, you not only have to look at the very beginning, the function you're putting in, but you also have to look at the final answer when you're talking about the domain. Is the answer for A going to be the same as the answer for B? Are A and B going to be the same? No. So remember, this is g of f of x. Again, remember, you cover up what's on the outside, you look on the inside first. F of x is 1 over x plus 2. So that's your g. So now, start building the domain. As soon as you recognize the input function, start writing what the domain is going to be. What's the domain of 1 over x plus 2? The domain is all real numbers except what? Negative 2. So right away I know the domain of this composite is going to be all real numbers except negative 2. I'll be adding more to my list once I come up with the final answer. So now I need to take 1 over x plus 2 and plug it into function g. So I have 4 over. Remember, I take the x out, and I'm going to replace it with 1 over x plus 2. So any questions?
What is it, negative 2?
Because the domain of 1 over x plus 2 is all real numbers except negative 2. You have to consider the domain of the input, remember, when you're doing composition. We don't know what the final answer is going to be yet, so we don't know what the domain for the final answer is going to be yet, so we're not there yet. How do I simplify this? What am I going to multiply everything by? Multiply everything by a what? X plus 2. So I multiply everything by an x plus 2. Remember, keep parentheses around that x plus 2. Distribute the 4, so that's going to be 4x plus 8, over. What's x plus 2 over 1 times 1 over x plus 2? No, it's not 0. It's going to be a what? 1. Distribute the negative 1 to the x and the 2, so that's going to be a minus x minus 2. So what's that denominator going to look like? It's going to be a negative x what? Minus 1. Again, if you factor the 4 out of the top, that's absolutely fine if you write 4 parentheses x plus 2 as well. So now remember, you have to look at the domain of your final answer as well. So what's the domain of 4x plus 8 over negative x minus 1? Negative 1, yeah. Okay. So the domain of this problem is going to be all real numbers except negative 2 and negative 1. Okay? So any questions on that one? All right? So any questions, guys, on doing composition involving these rational expressions?